I'd like the users to be able to search for multiple different stocks at the same time. This means starting multiple asynchronous operations simultaneously. We'll eventually need a way to know if all of it succeeded before we can add the result to the application. This means that I want to be able to call getStocks4 on the service class multiple times, each call with a different stock identifier. Let's assume that the user enters the different stocks separated by a space or a comma. We can split the input and get a list of the different stocks that we'd like to search for. Now we want to search for these using the service. Right now, we're kind of facing a problem. We don't want to proceed updating the UI until all the data has been loaded from the service. This means loading all the stocks. The way that we're going to do this is by loading all of these different stocks in parallel, and then wait for these asynchronous operations to complete before proceeding to updating the UI. Let's iterate through the list of stock identifiers, and for each identifier, we're going to call getStockPrices4. This will start an asynchronous operation, and the method, as you know, returns a task that is representing this asynchronous operation. We'll store this task. This will help us to keep track of all the asynchronous operations that we've started in this loop. Let's call this collection of tasks loading tasks. This will now hold a list of tasks that will in its turn, when they're done, return an IEnumerable of stock price. If we were to await each call to getStockPrices4, that would mean they would execute one by one. We want them to run in parallel, therefore we won't add the await keyword at this point. Instead, we'll capture the task, which is a reference to the ongoing asynchronous operation. If we were to search for 10 different stocks, this will create 10 different tasks that will pretty much run at the same time and invoke the API asynchronously. With this list of tasks, how do we make sure that all of these completed before proceeding updating the UI? Ideally, we'd want an aggregated result and then populate the UI with a flat list of all the stock prices. Fortunately for us, there is a static method on the task class that will help us achieve this. The method whenAll will allow us to pass an IEnumerable or a list of tasks. Using task.whenAll, we'll create a new task which will be marked as completed only when all the tasks in the list that we passed to the method are all marked as completed. Task.whenAll is an asynchronous operation. You know this because it returns a task, so you probably know what to do next. You will have to await it. The result of task.whenAll is in fact a list of all the results produced by the asynchronous operations. We can store this in a local variable that we're going to call allStocks. Since the result of each asynchronous operation is an IEnumerable of stock price, the result of task.whenAll will be an array of IEnumerable of stock price. For us to concatenate or flatten this list, we can use a link method called selectMany. Simply add allStocks.selectMany, and this will take all the different lists and put them in one big list of stock prices. We can now search for two different stocks by separating them by a space. When the data is loaded, we can see that the list is populated with the stock prices for both of these different stock identifiers. This here shows you how you can start off a lot of asynchronous operations and then use task.whenAll to make sure that you don't proceed in your method until all those different operations are completed. Now, I want to make sure that our operation completes within a given time, I'm going to introduce a variable using task.delay, which will allow us to get a notification when the particular time has passed. This creates a task, which will simulate that it takes the given amount of time to execute. We can now use this task produced by the delay method just like any normal task produced by an asynchronous operation. The idea here is that if it takes longer than a few seconds, we're going to cancel all the ongoing operations. You're probably wondering now how you would do that. First, let's store the task produced by task.whenAll in a separate task. Since we no longer use the await keyword, this doesn't produce the result of all the stocks. Instead, it's a representation of the asynchronous operation that is loading all the stocks. The idea is now to ask whichever of these two tasks completed first. To do that, we can use task.whenAny. This will give us a notification when one of the tasks that are passed to it completes. This method returns a task of a task. This means it creates an asynchronous operation, which result will be the first task that completes from the list that is passed to it. If the delay task is first, that one will be returned. And if the loading stocks task completes first, that will be the one returned. Let's await the task. The resulting variable will now contain a reference to the task that completed. We can compare this against the delay task. If they're the same, we're going to go ahead and cancel all the ongoing operations by calling cancellation token source.cancel. Every task that uses the cancellation token will now be signaled to cancel. Then let's throw an exception just to make sure that the flow of the application works properly. If it wasn't the delay task that completed first, it means we have all the stocks available. We can then grab all the stocks from the result property. Remember, it's completely okay to use the result property here because it's been properly awaited before. Run the application and search for a few stocks. You can see that it terminated the operation because the delay task completed first. We can see in the notes section that we got a cancellation requested. You can experiment with the delay and see how the application behaves. Obviously, a few milliseconds or a few seconds might be a little bit too short. I'm going to change this to 120 seconds, just to avoid any problems when running the application. An alternative approach to this would have been to simply use the cancellation token source to indicate that we want to cancel after a certain given amount of time. But this illustrates that we can initiate a lot of asynchronous operations that run in parallel, which we can then await as a chunk of operations that all need to complete before we proceed. We can also indicate that we want to wait for any of them to finish and then continue as soon as that is available. This gives us a lot of flexibility. I'd suggest that you experiment with the alternative approach of canceling the operations on the cancellation token source. You now also know how to use the async and await keywords together with task.whenAll and task.whenAny to understand how to build really powerful applications.